Alright, so I want to summarize this 2024 Toronto Town Spring Round Essay 5. It's one of the questions that didn't get solved in the actual exam by anyone. Like, no one submitted a solution, like, that was correct. But, I guess we finished it off in class. The question is, you have a polynomial with non-zero integer coefficients, and these are also roots of the polynomial. Okay? Prove that the coefficients of the polynomial have to be either 1, -1, or -2. Okay? So some pretty good ideas. I won't go through all the details, but basically you can show that all the coefficients divide the constant term um, by just subbing in the condition. Okay. And so the constant term is essentially the biggest coefficient in absolute value. And so if you sub in the constant term, it actually gives us a lot. So if you sub in the constant term, okay, and since everything will have a factor of the constant term, we can cancel that constant term, a naught, and then we get this equation with a1 by itself. But we know a1 divides the constant term, so it divides everything, so that means a1 divides 1, okay? So then we get a1 is plus or minus 1, okay? And so if we get a1 is plus or minus 1, so what we can do is we can keep canceling, okay? So you get a1 is plus or minus 1 here. That plus or minus 1 will either cancel with the minus 1 and get 0, or give you like a 2. Like a 2. So if it ever gives you a 2, then the a naught is a factor of a 2, right? So basically we have two cases. Either a naught has absolute value 2, okay? Or it always cancels to get 0 every time, okay? And so if it always cancels to get 0 every time, we get a polynomial like this, okay? Because if it's 0, then the next thing will actually, like a2 will actually divide a naught as well. So a2 will be plus or minus a naught. Okay, so then we get a polynomial like this, where all the coefficients are basically 1 or a naught. Okay, and it's basically, you should be able to conclude from this what happens. Okay, so basically we just play around with the plus or minus ones. So there's going to be a plus or minus 1. You can sub in and conclude that the a naught basically has to also be a plus or minus 1. Okay. Um, so because we'll have to, well, I'm getting a plus or minus a naught. Okay. So you need at least one, you need pluses and minuses to cancel each other out, so you'll get plus and minus a naughts. And so obviously, you want to conclude that it can't be 2, right? And so you get, so it's basically pretty easy to do, okay? And then we're in the case where the absolute value of the constant term a naught is 2, yeah? Okay, so if it's 2 and everything divides it, then everything's plus or minus 2 or 1, plus or minus 1, yeah? And you can assume the constant term's not 1, because then you're done, okay? Because then everything's plus or minus 1. So then you can basically assume the constant term's 2, right? Oh, actually, there's a -2 case as well we haven't done. It can be -2. Yeah,
You got approved. Yeah, sure.
yeah. But I think it'll be similar because all we did to get the contradiction was that both 2 and -2 were roots.
Yeah.
Yeah. Yeah. So long story short, if a2 is 2 and or -2, we prove that both 2 and -2 are roots. Okay, so both 2 and -2 appear as coefficients using the same divisibility arguments. And then we get something like this. Okay. And because it's skipping, so this is some of the even terms, some of the odd terms. Because it's skipping powers of 2, like the biggest power of 2 cannot be caught up by the other powers. Okay, because the coefficients are all like at most 2. and or you can consider it like mod 4 or mod 8 as well. Okay, but essentially you get this here if both minus 2 and 2 are roots. Yeah. Okay, so it's quite nice. Do you understand the summary? Were you listening to it?